Hello all, hope you're doing well. So in this video we are going to discuss about normality and some pH numericals. So I want to club these two because it definitely is having a lot of relationship. But before understanding normality in detail, we need to understand about chemical equivalence. So what this chemical equivalence is or what is equivalent weight. So we'll get to know why that is important because this concentration, that is your normality, is very much important. So normality is a concentration that we use specifically for pH related numericals. So normality is equal to number of gram equivalents divided by volume of solution that has to be in liters. So again, if it is an ml, then you need to divide it by 1000. So what is this number of gram equivalents? So if we try to understand, I'll define this part in a couple of minutes. Number of gram equivalents, that is equal to weight of solute divided by equivalent weight. So sometimes we try to use this entire thing. We open number of gram equivalents over here, weight of solute divided by equivalent weight. Now we go to the third part. Now what is equivalent weight? So I'm defining this entire formula in just three parts so that you can understand. Now sometimes what happens is like in different books they just write everything together, and what you people do is end up getting confused. So you don't have to confuse yourself. It's a very simple concept. You just have to understand it from a different angle. So equivalent weight is nothing but molar mass, or you can say molecular weight, or molar mass, like it can be your atomic weight if you're talking about a single element ion in a compound or a molecule. So atomic weight or molecular weight divided by n factor. So this is n factor is something very much important to understand. So now before moving ahead, like I'll come back to this entire thing again. So what is equivalent weight? First we need to understand. So, in short, before defining equivalent weight, what equivalent stands for? So we say equivalent. It's a substance which is defined as amount of anything, amount of it which combines with 1 mole of hydrogen atoms or replaces the same number of hydrogen atoms in a chemical reaction. So I'm taking from the standard hydrogen, but it's not always the same case. Like we don't have hydrogen in all the molecules and compounds. So we'll write equivalent of a substance is defined as the amount of it which combines with 1 mole of hydrogen atoms or replaces the same number of hydrogen atoms in a chemical reaction. So let's say we can say weight in grams of one equivalent is called as equivalent weight. That's why we always try to calculate this equivalent weight in grams, right? So now, if we want to take an example, let's talk about HBr. So in HBr, if we say that hydrogen is combining with 1 mole of bromine, HBr, we can even take water and we can take ammonia. Three examples because they all three are having hydrogen in it. So hydrogen over here is combining with 1 mole of bromine, And then if we talk about hydrogen, over here, how many moles do we have when it comes to, you can say, oxygen? So it's, if we talk about this entire thing over here, one hydrogen is combining with half mole. So if you can see from the formula, 2 mole is combining with 1 mole of oxygen. So if we want to have just, you can say, for all of these as 1 mole of hydrogen, it's combining with, you can say, with how many moles, you can say, of oxygen. So it will be half mole of oxygen. Now if we come to the ammonia, so ammonia will be 1 mole of ammonia is combining with how many moles of hydrogen? So 3 moles. So over here the nitrogen mole will be considered as 1 by 3 mole of nitrogen. So these are, you can say, the moles that we are talking about, right? Now, when it comes to equivalent weights in grams for bromine and oxygen and nitrogen in this, then we have to consider, you can say, you know, you can say the equivalent weights. So in other words, we can say 1 mole of bromine, oxygen, and nitrogen contains one equivalent. Like if we are saying over here, one equivalent, then over here, how many equivalents this oxygen is having? Two equivalents. Then for ammonia, how many equivalents? Three equivalents. So the equivalent weight that we need to calculate over here, let's say equivalent weight of bromine and HBr. So this will be, since you can say only one hydrogen is getting, you can say, bonded over here, 1 mole only, so 1 into the molecular weight of bromine, that is approximately 79.9 something. So this will be 79.9, right? Then if we go to oxygen, equivalent weight of oxygen, so this is, for oxygen it's basically half mole, right? So half into the molecular weight of oxygen, that is 16, so this will be 8. Then if we go to the third one, equivalent weight of nitrogen, so over here we said 1 by 3 mole of nitrogen, so again 1 by 3 into mass of nitrogen is 14, so this will be somewhere approximately 4.6. So these are the equivalent weights that we have calculated. So now whenever we are trying to calculate equivalent weight, it is not necessary that we always, proceed from hydrogen perspective. No, we can actually do it in number of ways, ways. Equivalent weight of an element, like if we talk about, it can be calculated by a number of ways that we'll try to understand from this formula which I have written, that is n factor. Because it depends, like what kind of compound you're taking, whether what kind of chemical reaction, what is happening, whether you're taking acid, base, or whatever. So that depends. So we always say, like the equivalence point of view, we call it as law of equivalence. So according to this, one equivalent of an element combines with one equivalent of the other. So point over here is that you go back to acid base neutralization, right? So let's, like for example, if I take HCl and if I am taking magnesium hydroxide, correct? So can you see over here, HCl can ionize itself into H plus, so it's giving one H positive over here, and we require only one OH negative ion in order to form water. If you go back to my acid base neutralization, the chapter, you can just remember like how, what's a, like, why acid reacts with, you can say, base to form salt and water. So basically your basically the motive of acid and base is to form water. So one equivalent of H positive ion reacts with one equivalent of OH negative ion to form one, you can say, mole of water. Over here, like I'm using the term equivalent because when it comes to acid base neutralization, so it's always going to be, you could say, one from each, one from the acid, one from the base. But over here, magnesium hydroxide is a diacidic base. So if we talk about diacidic base over here, so diacidic means like it can release two H positive ions. So what law of equivalence is saying? So when it comes to neutralization, only one H positive ion and one OH negative ion is going to be required from both the counterparts in order to get neutralized over here. So now according to, you can say, one more, like let's say one example, more example we'll take aluminium oxide. So equivalent weight of aluminium we need to calculate over here in specifically aluminium oxide. This is also called as alumina. So how can we calculate? So we know that 1 mole of oxygen contains how many, we can say 2 equivalents of it. Why I'm saying like this? I'm writing over here contains 2 equivalents of it. So again, if you go back to this part, so can you see, like according to this water, otherwise if you go back to this formula which I have written, equivalent weight divided by is equal to molar mass divided by n factor, right? So n factor over here has multiple meanings. So now n factor can be valency. So for aluminium, it's you can say, we can say 3 moles of oxygen combined with 2 moles of oxygen. So if we write it in the unitary way, 3 mole of oxygen combines with 2 mole of aluminium. Now, or we can say that 3 mole we have said, or it can be like 6 equivalents. If we say 6 equivalents of oxygen combined with, you can say how many, you can say or not 6 equivalents, like if you want to just take 1 mole of oxygen, so that will be nothing but 2 by 3, or you can say 1 by 3 also. So we can write like this, or 6 equivalents of oxygen combined with 2 moles of aluminium, or if we say 1 equivalent will be combining by 1 by 3 mole of aluminium. So if we want to calculate equivalent weight of aluminium, so this will be 1 by 3 into 27, that is the mass of aluminium, so this will be 9 gram. Now this is one way of understanding, otherwise we can actually define the n factor. Now coming to the n factor part, I'm just writing over here again, equivalent weight is equal to the atomic weight, or it can be gram atomic mass or gram molecular mass divided by n factor. So we are going to understand this n factor. So this n factor can be multiple things, can be acidity of a base, can be basicity of an acid, or it can be simple valency of an element, or it can be total cationic or anionic charge on the salt, or it can be total number of electrons lost or gained. So that is in the case of redox reactions. So we'll start from acidity of a base. So I took this example, magnesium hydroxide. This is diacidic base. So simply if we want to calculate the equivalent weight of this, the mass, molar mass of magnesium hydroxide, which you can calculate, divided by 2. So the n factor over here is going to be 2. That is nothing but the acidity of a base, right? So similarly, you can take example for aluminium hydroxide, you can take for any monoacidic base also. Then basicity of an acid. Now for this again, we need to understand about basicity in depth. So basicity, let's say if we talk about H3PO2, again if you go back to my videos, if you have watched, so H3PO2 is a monobasic acid. So N factor over here is going to be 1. That is the basicity of this acid. So over here, equivalent weight will be nothing but equal to molecular weight, you can say, of this entire molecule divided by 1. So if we talk about sulfuric acid, H2SO4, so molecular weight of H2SO4 is 98. If you can see, this is dibasic, divided by 2, that is the N factor. So this will give you 49 gram. Then we go to valency of an element. So aluminium oxide we discussed, Al2O3. So simply you can just see that from the formula, aluminium valency is 3. So what you can do, you can calculate the equivalent weight. So molar mass of aluminium oxide that you can calculate divided by 3. 3 is the valency, 3 is the N factor for aluminium oxide. So it can be for anything, right? It can be for polyatomic ion, it can be cation, anion, it can be a single element, it can be anything, valency of an element, if you're calculating like this. Then what do you understand by total cationic or anionic charge on the salt? So for this I'll be taking some different kind of salts. Again, you go back to my videos, you will be able to see the different type of salts. So I'm going to take double salts over here. So let's take carnallite. So KCl dot MgCl2 dot 6 molecules of water. This is carnallite. So if we need to calculate the equivalent weight of this molecular mass, you can calculate, and yes, you have to consider the water molecules in that. But when it comes to calculating the N factor over here, it's going to be just these two compounds. So I wrote over here total cationic or anionic charge. What's the meaning of this? So KCl dot MgCl2. If you can see, potassium chloride carries +1, -1, then MgCl2 +2, and this is -1. So over here you just add all the plus, right? So +1, then +2 over here. Total charge will be +3 from here. You just add total cationic or anionic charge I wrote. Then anionic, just for your you can say reference, or not reference, like just for clarity, -1 over here is into 2, so this will be -2 because we have two chlorine atoms. Then you add this -1, you will have -3 in total, right? So the obviously when it comes to salts, when it comes to these kind of, you can say, compounds, the cationic and anionic charge total will be always same. That's how they become electrically neutral. So over here the same number is same number we are getting. So whatever is the molecular weight of this, N factor will be 3. We don't have to consider water in this case because it's not an ionic compound. So we can take example of Mohr salt. So again, equivalent weight will be molecular weight of this entire salt divided by N factor. So N factor, again we need to find it out. Now ammonium carry +1 collective charge into the number of atoms. So I'm taking this one. Sulfate is entire -2. It's a radical. Iron over here is +2. How do I know? Because sulfate is -2. Do you see any whole bracket over here? We can predict from the formula also. So if you add it up, +2, this +2, then this +2, total is coming to be +4 and -4. So the N factor will become 4. That's a common number over here for cationic or anionic. So for this salt, Mohr salt, it will become, N factor will be 4. So this is how you can calculate for certain salts. You can calculate for acids, for bases, for different elements in a molecule, based on their valency. Now the last part that we are going to discuss, let's say if we have manganese in a particular compound carrying an oxidation number of +7 and it's changing into +2. Now first you need to figure it out based on the redox reactions, whether it's oxidation or reduction. So if you remember, increase in oxidation number is oxidation, decrease in oxidation number is reduction. So over here reduction is happening. But by a number of what? How many electrons this manganese +7 is, you can say, losing over here in order to change into +2. So it's losing 5 electrons, 5 mole of electrons. So the equivalent weight for manganese, whatever is the molecular weight, doesn't matter, divided by N factor will be 5. That's what I have written over here. It can be total number of electrons lost or gained in a chemical reaction if there is a change in the oxidation number. So elements can have more than one value of equivalent weight because manganese it can show from +2 to +7. It can show a wide variety of ranges. So I can show over here, if it is over here manganese plus 7 changing into manganese plus 5. So again it's reduction by gain of how many electrons. So over here just write its gain of electron, 5 electrons over here. So how many electrons it's gaining? 2. So the n factor over here will become 2. Again, just don't get confused. N is something that is used in multiple areas in chemistry. N is the number of moles. N is you can say a factor, you can say a common factor when it comes to empirical formula. N is a principal quantum number also. It's a number of orbit. And over here we are talking about as a n factor for calculation of equivalent weight. So n is something that chemistry people love, and it's going to be repetitive multiple times in the entire course. So over here, do remember equivalent weight is a changeable number. One value doesn't define equivalent weight. It's a changeable number. It can have more than one value, right? So let's talk about, so I'll write this point. So an element can have more than one value of equivalent weight. So example that we can take is FeO. This is ferrous oxide, and another one Fe2O3, ferric oxide. So if you can see, the oxidation number of iron over here is plus 2, over here it is plus 3. You can see from the formula oxygen is always on the general front is minus 2 always. So you can say if we are calculating the equivalent weight of iron over here, so this will be iron mass is 56, 56 divided by 2 for this case I'm talking about, and for this it will be 56 divided by 3. So can you see both the equivalent weights are different? Why? Because the compounds are different. How they are bonded, with how many atoms it's bonded, everything matters. So you can say the equivalent weight of a compound in grams which is taking part in a reaction is the weight of compound which combines with one equivalent of another compound. We can even say that. So now if we come back to the same acid base which we discussed before, now if I have this compound Na2CO3 reacting with HCl, so 1 mole of HCl is equal to 1 equivalent of it. Equivalent weight of Na2CO3 we can calculate by this chemical reaction. So let's try to write Na2CO3 plus HCl. So you can just think about it, what kind of salt this Na2CO3 is. It's parent acid and parent base. Parent acid is H2CO3, which is a weak acid. Parent base is NaOH, which is a strong base. So if you think, it's a basic salt reacting with acid, so it's a type of neutralization. The only difference is that one of the product will be carbon dioxide because you have taken a carbonate on the reactant side. So you have NaCl, it's a displacement reaction, right? NaCl over here if you can see, NaCl plus water will be released because it's a neutralization reaction, and carbon dioxide. So we can say now if we balance it, this will be hydrogen, we have 2 on the right hand side, so 2, and over here now it's balanced. So we can say 2 moles of HCl is combining with how many moles of Na2CO3? 1 mole of Na2CO3, right? Or we can say 2 equivalents of HCl combined with 1 mole of Na2CO3. So now if we say 1 equivalent of HCl will combine by half mole of Na2CO3, correct? So in this particular reaction, what will be the equivalent weight of Na2CO3? This will be half into 106. 106 is the molecular mass of Na2CO3, and this will give you 53. Now if we have a certain you can say different reaction, right? Different reaction in the sense, like over here if you can see both this you can say both the sodiums, or you can say one, like Na2CO3 can displace like two Na positive ions, right? And it is forming NaCl carbon dioxide. What if you can say instead of NaCl we have a different product? If we have sodium byproduct which is getting formed and NaCl, like that's an intermediate product. It's not, you can say, the final product. Again, it will change into you can say NaCl and water and carbon dioxide. But what if we have that kind of reaction? Then also the equivalent weight can be changed. So we'll come to this part. Na2CO3 plus HCl giving us NaHCO3 plus NaCl. So one equivalent of HCl combines with one equivalent of Na2CO3. So since they both are 1, so obviously in this reaction equivalent weight of Na2CO3 will be 1 into its molecular, it's a, you can say, gram molecular mass. This will be 106 gram. So can you see in these two equations, since the product is different, you can say slightly if we change the reaction, the equivalent weights can be different. So compound can have different values of equivalent weights, right? Now we'll come to the some of the questions that we are going to understand. Now this question, find the equivalent weight of H3PO4 in the reaction. So forming calcium biphosphate and water. So if we need to balance it, so hey, it's balanced. Now, according to this, like we need to find the equivalent weight of phosphoric acid in this, right? So if you can see, out of phosphoric acid, only two H positive ions are released, and one of the hydrogen is still there with the salt, calcium biphosphate. So calcium biphosphate is an acid salt. So we can say 1 mole of H3PO4, that will be equal to molecular weight divided by n factor. So the n factor we need to decide over here. So we can say 1 mole of H3PO4 replaces 2 H positive, or you can say 2 moles of H positive ions. From the equation we can see, right? This is tribasic. So out of 3, only 2 are getting released and 1 is still left behind. So replaces 2 moles of H positive ion. So over here molecular weight of phosphoric acid is 98, divided by n factor will be 2 in this case and not 3. So this will be 49. That is the you can say equivalent weight of H3PO4, right? So one more question related to normality we will take if we have a direct question. So calculate the normality of 0.321 gram of sodium carbonate when it mixes in a 250 ml solution. So over here we know normality is equal to what? Number of gram equivalents divided by volume of solution, that is in liters. So I'll be writing like this: weight of solute divided by volume of solution, that is in liters, into equivalent weight. So if we want to open this equivalent weight, so weight of solute we already know, that is 0.321 gram. So now weight of solute is given over here 0.321, volume of solution is 250 ml. So into 1000 because it's in ml, so you have to convert it into liters. Then into equivalent weight. So we did Na2CO3 before, so it's 106, and the N factor for sodium carbonate will be 2. Why? Because it's having two sodium ions, or you can say, you can say it's basically, we just discussed about that with when it comes to chemical reaction, or you can say for these salts also, the total cationic and anionic charge. So individually if we talk about salt, so it's going to be plus 1 into 2, and this is minus 2, so 2 is the n factor, so divided by 2. So after solving, so you can solve it, you can take some time to solve it, so it will be 0.024 normal. That's the answer. So they can ask you anything out of it. They can ask you to calculate the equivalent weight. Depending upon the question, they can ask you to calculate volume of solution, weight of solutes, number of gram equivalents, normality, anything. And one more thing that you need to remember, normality is equal to molarity into n factor. This short, you can say, hand formula is for those questions where they ask you to convert molarity into normality. So you just have to multiply the molarity concentration into n factor, and you'll be able to get the answer. So this is like one part of the video that I'll be discussing. In the second part, we'll be discussing about pH numericals. So stay tuned. Please like, subscribe, and share this video if it was helpful. You can share it with your friends also. Thank you so much.